All right, we'll get rolling here. Thank you everyone for joining the BVLOS Sync today. Today we're being joined by Rob Knockenhauer and Austin Rains from Frontier Precision. And just to get things rolling, I'm going to give Rob and Austin a minute each to kind of introduce themselves, who they work for, and kind of what they do. So, Rob, if you want to go ahead and kick us off, and Austin will follow behind.
Yeah, you bet. Thanks, Adam. Yeah, Rob Knockenhauer. I'm the Director of Regulatory Affairs at Census Technologies. And my role is I basically help our clients and ourselves actually get permissions from the FAA to do more complex operations typically outside of Part 107, beyond visual line of sight, above operations above 400 feet, operations with people and vehicles, that sort of thing. So looking forward to talking to y'all today.
All right, thank you, Rob. Yeah, so I am Austin Rains. I'm a part of Frontier Precision, and more specifically, a part of Frontier Precision Unmanned. I am our Southern United States Regional Sales Manager, and I'm our responsible party on our Beyond Visual Line of Sight waiver for our Centero 5. My background is heavily in surveying and in engineering, and so that would probably be our predominant use case that we have used our internal BVLOS operations. They have been primarily in the surveying space. So that is where we really gravitate toward. But we've been partnered with Census just over 2 years now. And so they are one of our manufacturers and our recommended beyond visual line of sight vertical takeoff and landing fixed wing. And so, yeah, I'm also excited to talk to you guys today.
Thank you guys so much. And Rob, why don't you go ahead and get us started here? And we're going to talk a little bit about the 10 Part 107 kind of waivers you can get.
Yeah, awesome. Thanks, Adam. Yeah, so basically just to kind of like level set here, there are 10 different rules that are subject to being waived from Part 107. And these rules, the one that's pretty high to emphasize here is the 10731, which I'm sure a lot of you know about, which is the beyond visual line of sight, 10731 is the requirement to fly within line of sight, and to get a waiver to that would allow you to operate beyond visual line of sight. And that's a kind of the holy grail for the industry. Some of these other ones are can be related. 10733, if you're doing operations that are BVLOS, that you're using visual observers to monitor your airspace, you would basically request a relief from 10733, where your visual observers would not be watching the drone either. And then next would be 10739. 10739 is the operations over people, which is kind of the companion to 107-145, which is the operations over moving vehicles, or rather there's a barring from doing operations over people and moving vehicles under Part 107, unless you've got a waiver that allows you to do it. So next is 10751. So 10751 is the approval that allows you to, well, it's a restriction that basically says you can't operate over 400 feet. You can't operate, within 2,000 feet of a cloud, horizontally, so adjacent, or within 500 feet below a cloud. So if you've got a cloud ceiling where your ceiling's at 500 feet, you're basically grounded. So that's another one of the approvals there. The next one is a little more uncommon, is 10737, which is the ability to fly, basically have crewed aircraft give right away to uncrewed aircraft. It's a very uncommon approval. I don't think I've actually seen one issued. Next is 10741. That is basically the permission to operate within controlled airspace. That's kind of handled largely by Lance. And so then there's 29 is the night rule, and we're just going to press on. All right, they're very good. Thanks, Adam. And next up, we're going to talk about some of the common waivers that are out there. So the ones that are highlighted here is the shielded approvals that we've had, we and many other folks have had luck getting approvals for. What shielded means is that you're able to operate within, as this graphic shows you here, within 100 feet, 50 to 100 feet, kind of depending on what you have for equipage on your aircraft.
above either the ground or, in this case, power lines or any other type of structures. Can you go back a slide there, Adam? All right. So next on the list here is nationwide BVLOS. We highlight that because that's it's a performance-based approval. So what we've been able to help put together for a number of our clients, and others have done this as well, is you create a list of criteria that the FAA accepts as a way for you to evaluate a site for suitability for doing BVLOS. And so these waivers will allow you to basically determine, following a set of criteria, to determine if an area that you might want to do a BVLOS operation in is allowed under the approval that you have. The advantage of that is that you don't have to apply for a new waiver for every time that you're doing an operation in a new location. So that's a great use case that we've been able to use here at Census. And beyond that, there's other ones here. There's the tactical BVLOS waiver. That would be tactical is kind of an interesting term, but it's basically around the corner type of an operation. So if you're doing like a bridge inspection or something to that effect, where you have your aircraft out of sight just on the backside of the bridge, that is technically a BVLOS operation. So there's been specific waivers that have been granted just to do those types of inspections where you might lose sight of your aircraft, but you're pretty close to the structure that you're inspecting. Next is drone as a first responder. So drone as a first responder, you don't typically see as a 107 waiver. Those are typically conducted operations under Part 91, but they could be conducted as 107 operations. And again, those are typically BVLOS with ops over people, and then kind of a limited or kind of different rules as far as like how visual observers are used in those use cases. An EVLOS extended line of sight waiver, which is many waivers are actually BVLOS waivers that have been approved that you'll see are actually extended line of sight waivers. We've actually leveraged that pretty frequently as well. High altitude is the 107.51 Bravo, which is what I discussed earlier. Next, kind of getting into remote operations. So those are the drone in a box solutions that a number of companies have put out there. Folks like Percepto and Skydio, DJI, American Robotics have leveraged those for doing remote inspections of typically like different types of assets like substations and maybe like refineries and that sort of thing. And then this last bit here is the operations over people and moving vehicles. That is that's a nice, it is a waiver that you can be granted typically if you have a parachute recovery system equipped with your aircraft, or in the case of how we've leveraged it, we've been able to cite some of our operational history as a basis of assuring that we have a high enough level of reliability of our system to allow limited exposure ops over people and moving vehicles, which has been quite useful for some of the use cases that we've encountered. So I want to just quickly get into the waiver process here and like how you actually go through and put together a waiver. So what you want to do out of the gate is you want to describe what it is you're trying to accomplish. And you need to kind of run through your operation end to end and spell it out in a way that's pretty clear to understand. It's one of the things that I find in working with different people is that you get so focused on like the details of the workflow that by the back of your hand, that you might, as you're trying to describe it, omit steps that you just have taken to accept as common sense and that need to be articulated, because the people at the FAA that are reviewing it aren't going to know those details. Once you've done that, you basically want to take a closer look at the risk of the operation. So this slide here kind of shows a way to kind of weigh your different risk scenarios for your air risk. Like if you're operating in an area that's in the middle of the country that has no airfields around, it's going to be a very different risk profile than if you're operating in a more suburban or urban area. And then for the ground risk, there's a similar thing. I mean, there's a correlation. If the air risk is high, the ground risk is typically high as well. So there's a couple of exceptions to that. So for instance, the Class Bravo Airport in Pittsburgh is pretty rural all around there, but there is higher air risk because you got a lot of traffic coming in and out of that facility. All right, so next, once you've identified your risk, you basically want to go through and identify how you're going to mitigate those risks. And basically, for an example, if you're in a situation where you're in an area where there's higher air risk and you're aware of that, you want to cite that either you're going to use visual observers to monitor that airspace and communicate that information directly back to the RPIC, or you're going to use a tool that's like an onboard detect and avoid system, similar like some of like the Cassia system that we use on the Centero. And it could be a simpler version of just airspace awareness as an ADS-B sensor, which if you're operating in a mode CVAL, and most aircraft are required to be broadcasting ADS-B, that becomes a pretty viable air risk mitigation strategy as well. Same thing on the ground risk. If you're looking at, if you're flying over areas where you're in a city type of area, you're going to identify that, okay, I'm going to make keep out zones out of these certain areas where I'm not going to fly over parks or stadiums or that sort of thing. So those are simple examples. You can get into deeper levels of nuance from there. Once you've got all those risk mitigations defined and your CONOP defined, then you want to go through. The final step is to go to the FAA's website, download the latest waiver safety explanation guideline question set that they published there, and it's under Part 107. I don't remember the exact link exactly, but if you type in FAA WSG Part 107 operations, something to that effect, you'll come up with this the link to that list. So you just got to be careful because you want to make sure that you get the latest one, because there are a couple of older versions kicking around there as well. The latest version actually was there's some slight tweaks that came out in June of this year. So, and then you go through those questions, you answer them very plainly. Just, make no assumptions. Just you have to answer it as if you're explaining to somebody who has no idea what it is you're talking about. So, and then that's it. Once you have all that information together, you package it up, put it in the drone zone, and send it in, and you're on your way. All right. Yeah, so common mistakes, I kind of got into this a little bit. So, operation information. So if you don't include, enough information about your CONOP to help the evaluator to understand what it is you're trying to accomplish, they're probably going to push that back. If there are some glaring misses in your risk assessment and the mitigations, they're going to get pushed back on that. If the WSEG questions are not answered completely, you'll probably get a pushback on that as well. So, all right, over to you, Austin.
All right, thank you, Rob. Now I'm going to get into some of the fun stuff of applying all of the things that Rob just spoke about. So we do have an active waiver that Census, Rob, he did draft for us, and so we submitted it just like he described through Drone Zone. You wait a specific amount of time, then you will get a blanket BVLOS waiver. That's the one that we have. So ours is non-geographically constrained. In Class G airspace up to 400 feet with utilizing VOs and by doing an area analysis and things of that nature. And the way that we have really been able to just expedite what we are doing currently with our portfolio. We carry over 30 different manufacturers in the UAS space, including aircraft, multi-rotor, VTOLs, sensors. And so we're always trying to find a way to be more efficient, like I'm sure you guys all know. And what we've been able to do, what you see here, is a recent milestone that we've been able to do. We were able to conduct a full 2,500 acres of fixed wing yellow scan LiDAR at an AGL altitude of 60 meters with a 50% overlap. And we were able to do that in a total of 8 flights. And that's pretty incredible in terms of the efficiency. And when you correlate that to how you would typically conduct this in a multi-rotor fashion, or even in a vertical takeoff and landing fixed wing that does not have the BVLOS capabilities, because what we were able to do is pick a very centralized location in this reservoir in southern Texas, and we were able to just stay there. So we had our operations in one area. We did not have to maintain our visual line of sight and keep moving and having other launch and land locations. If you understand line of sight and you're at around 2,500 acres that's heavily vegetated, maybe there's some elevation tolerance there, you're 100% going to be losing line of sight very frequently. And so to stay within Part 107 requirements, you're going to need to move where you're taking off and landing to maintain that line of sight. But with the BVLOS approval, with our station VOs, we were able to do this entire 2,500 acres in a single day, extremely efficiency, always launching, landing from the exact same location. And so that was a big win for us because this was a field to finish, survey grade accurate LiDAR job that we wanted to do as efficiently as possible, and just to pretty much prove the capabilities of the system, because we'll get into this a little bit later with some future slides. But you know, there is, in the surveying world, when you're dealing with high validity and high accuracy, there's always the I guess the worry that in a fixed wing environment with the added speeds, the added vibrations, there's going to be a decrease in the accuracy that you can attain in a LiDAR or a photogrammetric sense. And so what we do at Frontier Precision, being not only a product vendor, we are doing field to finish services and consult, and pretty much just want the industry to accept these new pieces of technology. So we want to prove that validity. And so, Adam, if you can go on to the next slide. And so here is another achievement that we've been able to do. We actually worked alongside with Census, and this was our longest at Frontier Precision's linear approach that was BVLOS. So we did a full 30 miles of beyond visual line of sight transmission line, and so that was 15 miles down and 15 miles back. So the same. We actually flew this with this one a little bit lower, so we did fly at 50 meters versus 60, but we did still achieve that 50% side overlap, and we're still able to achieve just under around that 200 points per square meter on average. And that is just a single flight line. So if you think about the 50% overlap, if you are covering 50% of each flight line, you can double that points per square meter. And so when we're getting into this is a nadir view of the entire 30-mile corridor that we were able to fly in a single flight. So we launched on the southwest side of the picture on the left, and then we flew at around an 18 meters per second speed all the way down. Then we turned, and then we came back, utilizing LiDAR knowledge and understanding of the capabilities of the inertial measurement unit on the yellow scan system. So we planned utilizing arterial mission control, which has been a huge upgrade from the Centero 4 to the Centero 5, by allowing you to, you know, throw in those IMU calibrations that are necessary to maintain that validity approximately every mile on this corridor. And so utilizing a software like AMC or arterial mission control, it is so useful, and it's really just made mission planning and conducting these long linear or large acreage LiDAR missions specifically much more simple. And so this is getting into a little bit of survey grade and how it ties into BVLOS. So if you see here, this is the trajectory or the flight path that we did on that 2,500 acre LiDAR project. And so you can see what we do is we actually section it out, because understanding LiDAR, and you know, we really partnered with Census when they integrated yellow scan LiDAR. When they were able to do that, we were a huge resource for them, and they were a huge resource for us to really bring this to a BVLOS fixed wing front and prove that you can do this efficiently, and not only efficiently, accurately. And so that's what we do at Frontier, is we not only use this stuff, we're going to train you how to do it. And by breaking up those acreages in smaller sections, it allows you to maintain the validity and still maintain the efficiency. And this is just proving that. So what we do is we process everything, obviously, in terms of the proprietary LiDAR manufacturer software. But to alleviate all bias, we will take the processed LiDAR and we will bring it into a third-party software that has no affiliation, and we will run a residual accuracy assessment on that. And that's what you see here. So we have a points to surface report. So what we did is we flew with yellow scan LiDAR on the Centero 5 platform, full beyond visual line of sight. We processed the LiDAR, we referenced it the correct way, we classified the above ground features from the ground, and then we generated a digital surface model on the full density ground classified data set. And then once we have that, what we'll do is we'll take X, Y, and Z data from a third party. So we had a survey group go out there and lay GCPs ground control points, and they shot the center of those. They also collected some natural ground shots just to reference the Z. And so what we see here is a survey grade residual accuracy assessment. And so if you see the highlighted values on the right hand side, that is showing that compared to the same location on the LiDAR generated surface, in turn, all of our LiDAR that we collected with a beyond visual line of sight fixed wing and a yellow scan sensor integrated, we were able to be sub-10th on the residuals. And if you know the surveying world, if you can achieve a residual accuracy on the X, Y, and Z that is sub-10th, that is high validity. Any licensed surveyor in any state is going to be very pleased with that. And so it proves that we can not only collect this data, because it's one thing to collect LiDAR, whatever type of platform you want to use, but it's another thing, can you prove the accuracy of that data to actually use in a surveying industry or in an engineering industry or in a design industry? Because what's the point of flying this very cool platform with this cool LiDAR sensor if in the end the data is not going to be accurate to use? And that's what we do, is prove that accuracy and prove it efficiently in a beyond visual line of sight front. And then lastly, I just did throw this in there, that same area we were able to fly LiDAR, and then the next day we flew photogrammetry. And so that is able to be, this is just another one of their payloads. Obviously we do a lot of LiDAR, but we also have a high need for photogrammetry. And so for this one, we did pull all the topographic data from the LiDAR, but we also wanted to develop a 2D orthomosaic. And so we were able to derive that utilizing the Sony ILX LR1, which is a 61 megapixel camera that Census has integrated into their platform. And we flew at 100-meter altitude, and we're still able to achieve just around that 1.5 centimeter per pixel ground sample distance, which is extremely high resolution. And so you can think of, if we flew at 60 meters for the LiDAR just to bring up that point density, that when we are flying higher, we're able to even cover the ground even that much faster because we're gaining 40 meters of altitude. I think that might just be what I have. Yep.
All right, thanks, Austin. That was awesome. Yeah, so as Austin clearly pointed out here, there are a lot of use cases that we have for the system here, and it's been a great. It's one of the things that it's true what Austin said there. It's just like, if you can't actually get any utility out of this ability to fly beyond visual line of sight, like, what's the point, right? So this has been a huge win for the industry, and it's been great. So we're going to go through a couple of use cases here. So this first one here is Flagler Beach. So we have our neighbors to the north out of Daytona is Flagler County. So Flagler recently has been using one of our systems since I guess earlier this year, and they have about 18 miles of coastline in their county, and basically they are constantly needing to making assessments of the erosion of that of the beach. And so the Centero ends up being a great platform for that, where they can actually operate now using their recently gained approval to do operations over people and moving vehicles. They can do kind of those limited low exposure operations over the beach. They can't do, like, if there's like big crowds on the beach, they can't run the operation, but they can certainly run without it. And now they can use that to LiDAR scan the operation, LiDAR scan that entire beach with a single operation, flying 9 miles one way and then 9 miles the other way to give you that whole 18 miles of coverage. So it's a great use case of the system. So all right, is that it, Adam?
Yeah, I appreciate that. We will kind of into our Q&A side now. I'll kind of throw up this graph here. USI actually gave us this in one of our previous ones, but it kind of just gives a cool breakdown of how drones are being used in the industry in different ways. But yeah, if you guys have any questions, feel free to drop them in the chat. While you guys are typing, I have a couple questions for Austin and Rob, and I'll go ahead and start off with Austin here. Austin, becoming a BVLOS operator isn't necessarily something that happens overnight. What did it take for you to become comfortable, flying BVLOS and operating BVLOS?
Yeah, it's a good question. There's experience that is definitely useful. Just from flying other platforms, understanding how to fly within line of sight. But what Census does and what we do as well now, selling these products and utilizing them, is there are accredited institutions, the Unmanned Safety Institute being one of them. And really, from the week in-person training that you do with them, they take you through so much risk mitigation, starting from a simulator to ground risk mitigation to air risk mitigation, and really flying the aircraft in a lot of difficult scenarios. And then what you're going to be typically utilizing, especially at Frontier, is going to be very autonomous, not really doing much manual flying. But during the training, so we went through the Unmanned Safety Institute. They were great. You're going to fly that aircraft. They're going to put you in positions that are going to replicate hazardous situations that could happen in very non-common times when you are flying the aircraft, and they train you on how to get out of those. And there's a lot of confidence that can be built with this platform, and you can just correlate that confidence with the FAA allowing it to be a BVLOS approved aircraft. They have a lot of fail safes, which every aircraft on the market today is going to have some sort of fail safe. But to be a BVLOS approved aircraft, there is more confidence that you can have, because you have to understand that the FAA has approved this as an aircraft that if you don't have eyes on the vehicle and all you are basing it on is telemetry, ADS-B, and it has an issue, or it encounters a difficult situation, you have to have confidence in the hardware that the FAA has given it, because it does have the technology. It's got the onboard CASIA system. It has ADS-BN. That all that married together, there's a lot of safety that goes into that. There's a lot of safety nets, and so by having all of that, it does give the user confidence in training, and then it's really getting out there and flying it. But after that training with USI, that is going to be a requirement anytime that you guys implement this or purchase this and integrate it into y'all's current UAS programs. You will go through that week training, and there is a online portion that you'll go through that just gives you a good baseline, and then you will be on site with a licensed trainer. If you're working with Frontier Precision, we'll be out there on site as well, and we'll train you on all the payloads. And obviously, we utilize this, and so it's not going to be something that you're going to be delivered this very, very big BVLOS aircraft that you are just going to be supposed to be able to just fly out of the box without any training. There's going to be a lot of things that are put in place to where you have the confidence when you are operating by yourself, that you will have the ability to do so because you have gone through the training. And so that's, I think, what's the biggest thing for me, is just going through the training that is required, and then just getting reps on it when we're utilizing this in a autonomous fashion.
Thanks, Austin, for that. And kind of to summarize back to, it really just sounds like you said, trusting the hardware, the training, and really getting time with the system are three big points to gaining confidence in operating BVLOS missions. And Rob, next question for you. I know you probably won't have any stats for this one, and you probably won't be super happy with this question, but do you think, how do I say this? Does the average operator truly understand the value of BVLOS and kind of what they can get out of it? What do you think on that, Rob?
That's I think probably the average operator doesn't fully understand the value of BVLOS, because there's not a lot of operators that are actually leveraging BVLOS, and so it's what we found with the people that we've worked with is that it's a learning process. We've been able to articulate, when we show these slides, over and over again, right? And it's just like, and there's a message there, and I think what really is the main point is that you're operating in a place where now you can get to places that are a little farther than you could get to from just the side of the road, and so that ability to be able to go out 15 miles out and back, and particularly if you're able to leverage low altitude shielding, which by the way, we're seeking to actually get even higher permissions above the beyond the 100 feet that we are able to use now. You're starting to be able to leverage the true value of the system. So in that shielded context, going out that 15 miles and back, it allows you to get to places that may be difficult to just physically access, you know. So that's certainly been some of the people that we've been working with are working in areas where there could be 10 miles between roads or access points to their right of way. And so that's where it starts to become a part of the value proposition. There's other, you know, use cases like, you know, for some surveying operations, it's like, you know, maybe BVLOS isn't necessary. I mean, it certainly could help you to kind of give you broader reach, you know, if you're able to fly higher. And I think in the surveying application, you know, if you're using like a higher resolution camera for doing, you know, larger photogrammetry, you know, BVLOS is starts to become part of the value proposition. Certainly where we've seen it most has been in the linear infrastructure space. I don't know if that's, I don't know if that, and as far as like people recognizing that value, I think the people that are using it in that application are starting to recognize it, because what it's starting to do is there, you know, when they might have considered calling in a helicopter or an airplane to do like a linear piece of linear infrastructure that's just difficult to get to, they now could probably pull over to the side of the road and actually run a BVLOS flight from the back of the truck or the MCC that they happen to have with them. So.
Thanks for that, Rob. And kind of to piggyback on that question, Austin, you know, you're out in the field with clients on a pretty regular basis, and new customers kind of hearing all the different use cases out there. How often do you hear what these people and operators are doing, and you're like, wow, like if they just use BVLOS, this project would be so much easier. Like, how often does that happen?
Yeah, I would say very often. You know, we also do a lot of proof of concept field to finish services, and a lot of those, you know, we'll get an opportunity that someone wants us to go and fly LiDAR, fly photogrammetry, fly multispectral for vegetation encroachment or just whatever, planimetrics or just topo, of, like Rob said, long linear. Typically, it's going to be something in overhead power, so transmission or distribution corridors. And you know, it's great for large acreage in terms of, you know, being able to be efficient, like I showed you in the presentation. But Rob's right. Where this thing really shines is when you have a center line of a corridor that you need a specific swath width on. And traditionally, you're going to have to move. Maybe you'll have a system that's large enough that you can maintain line of sight. If you're, you know, out where I am in Texas and it's flat enough that you could maybe push it a mile to a mile and a half, both ways, and then you're moving, versus being able to literally conduct, like I showed you in the presentation, 15 miles, and that's down and back. And you can think if you were able to do 15 miles every single flight, and you know, you have an 8-hour day, let's say, and let's delete, you know, an hour of that just for I guess moving to maintain the longevity. But if you were able to have 15-mile increments versus 2 to 3, that's where it really shines. And we get that all the time. And every single time we get an opportunity or an inquiry that someone is wanting to do long linear assets, you know, I do a lot in the pipeline industry. So pipeline corridors, they need to do either as built or after builts of a pipeline corridor. And you know, you're out in the Permian Basin, it's the perfect situation for BVLOS. You're gonna be in you know, you're gonna be in Class G airspace typically. You're gonna be rural areas, and versus having a multi-rotor or something that you can't go BVLOS, you know, it's so eye-opening when people see how efficient they can be in a linear approach when they do have the BVLOS capabilities. And I mean, just think about it going from 2 to 15-mile increments. You know, when we get the point to point, you could push it 30 miles every single time. I mean, it saves companies money. And whenever you see the efficiency that's gained, I mean, the ROI on the aircraft and the product, I mean, it just makes sense when you're able to see that you're increasing your efficiency by, you know, 10-fold, 30-fold, whatever it is. And so I would say that's the biggest eye opener, is when people have these long corridors that they need to collect data on, and they're limited to that line of sight, and they are interested in the BVLOS because of the fact that that's what they need to do. They just need to be able to allow the aircraft to fly, and also, you know, the Centero 5 being full cellular connectivity, that allows it to really be able to do true BVLOS, because we're not limited to that long range radio that, even if you've got a great long range radio, you're pushing it 3.5 miles maybe, and there's still limitations on even if you were BVLOS or not. So having that C2 link that has been integrated to the Centero 5 and allowing to push it with cellular connectivity, with a redundant long range radio, it just really allows companies to be efficient. And whenever you can just make them understand that, and make them understand that the investment will pay itself on the increase in efficiency, it's eye-opening. And that's what we do, is we just show that to them, and then they see how they can work it into their current workflow that is, it may be in their eyes very efficient, but it's not efficient when you put it into comparison with what you can do with a fixed wing BVLOS.
Thanks for that. Like I said, if anyone's got any questions, feel free to drop them in the chat. Rob, kind of last question for you I have here. We kind of touched on a little bit like the operations over people, but can you dive a little more into that waiver and kind of give us the field of view, like where is that even applicable in the United States?
Yeah, happy to do that. One thing I just want to echo what Austin said earlier, which is about the C2 link. So, that's one of the elements of these BVLOS approvals that we're getting, is that assurance that we're going to have positive control of the aircraft regardless of where it is along its flight line. We do have, the aircraft is programmed to initiate, a return to either home or to an alternate landing location as part of the programming in preparation for running those BVLOS flights. But really, the thing that has been the game changer has been that cellular C2 link. So I'll a shout out to Elsight for their support and kind of providing that capability to the Centero. It's been amazing. As far as the operations over people and moving vehicles, so the way we're doing it is we do have, it's a limited exposure. So we can't maintain sustained flight over people. We can't maintain sustained flight over roadways. But again, where we really leveraged the value of this is in the Flagler County use case, right? Being able to fly that shoreline and occasionally passing over people along the way is acceptable. And then beyond that, Austin's highlighted the pipelines and the power lines, and railways, or so basically anything that's right of way is really where that type of an approval comes into play. So recently we helped to get New Jersey Transit in approval where they're allowed to do operations along their rail network, and we were able to put that request together in a way that they're able to run their rail network regardless of what the population density is of that rail network. There are other buffers of, the ground risk buffers that we have to take into consideration that are going to inherently limit it to the higher, I would call it low density urban is kind of the best way to describe it, but certainly some of the more high density urban areas they are not going to be able to operate the Centero in. But in those higher density areas that they can operate in, this type of an approval allows them to operate over the roadways, so they can cross the roadways that are along their right of way. So they can, and any roadway is, I think, is what the FAA has granted us in this case. So again, it's that recognition of the reliability of the Centero that they've approved to allow New Jersey Transit and some of the other operators that are using these types of approvals to do those types of linear operations. So that's really kind of the sweet spot.
All right. Well, thank you for that, Rob. That's all we have today. I don't see any questions in the chat, but I do want to give Austin and Rob one more minute if they have any more closing thoughts to go ahead, and we'll kick off with Austin here and end with Rob. So if you have anything, Austin, feel free.
Yeah, thank you, Adam. Thank you, Rob. Pretty much what I'll say is that when we brought on Census and we partnered with them, it was a large portion was because they integrated our recommended LiDAR manufacturer, Yellowscan. But that was where it started. And then once we really saw what you can do, and we're a product sales company first. We obviously train our customers, we consult, we do field to finish services. But whenever we even were able to see just the efficiency, the increase in efficiency, and the applicability of BVLOS, just for a company like us. And we're not doing services as our first revenue stream. And so that's something that if we are able to see just the application that it can be applied, and we work with so many different types of companies, and I've seen this actively being utilized in the correct way, and what it's really done in terms of ROI for companies. It's really eye-opening. Sure, I'm not going to sugarcoat it for you. There's going to be an initial investment, but once you really break it down and understand how much money this will save you, and then in turn make you, whenever you apply it the correct way, it's extremely beneficial. And also just in terms of what it can do in terms of merit for your company, in terms of getting projects, having a BVLOS capability. We've seen that just in terms of a marketing standpoint, when you're able to say that you not only have a UAS division and you can do aerial LiDAR, you can conduct aerial photogrammetry, whatever your application is, but you do have the BVLOS capabilities to do so. That's just going to open the doors up to all this other opportunity of companies hiring you on as a service provider, or choosing to go with you because you have that additional certification, being BVLOS approved and having a capable aircraft. So I'll say that it has been extremely beneficial for us to implement this into our workflows, and it has been extremely beneficial for our customers to implement this. And there's never been a decrease in efficiency for any of them utilizing this. It's only been an increase, and there's so many different ways you can apply this technology. So I would just leave you with that it has been a huge resource for us, and I know it can be for you guys as well.
Thanks for that, Austin. Take it away, Rob.
All right. Yeah, Austin, thanks for joining me today. This has been a really great conversation. And Adam, thanks for putting this together again. And, I guess the thing that I want to point out or emphasize here is, Part 108 is coming, right? So it is the new BVLOS rule. And some of the things that are going to be highlighted in that BVLOS rule is the training. So Austin touched on that earlier, and the requirement for training. And the reality is BVLOS is hard. I mean, it's a different step. The risks are higher, and as an operator, you need to be well aware of that risk profile, and the FAA is requiring it. So if you look at the waiver safety explanation guideline questions, you will see that there are specific questions regarding what training that your operators are going to be, your pilots are going to have before they run these operations beyond visual line of sight. And they're really, that's something that they want to see, because 107 is, I mean, there's some information that you need to understand about airspace and weather and how your systems work that is incorporated in there. But the reality is it's just a test, right? There's no practical component to it, and so there's the bar is fairly low. And in that regard, it's if you're in a position where you're looking to go to the BVLOS space, you have to kind of understand is there is a lot of there is the upfront cost of the hardware. There's also the upfront cost of the time that you need to invest in to actually put your ducks in a row, to have your procedures in place to satisfy the FAA requirements that you're going to run this safely. So that's kind of the biggest piece there. But once you get over that hurdle and get it there, it's true. Those efficiencies that Austin's referred to, can be unlocked, and they're there and they're real. But it is it's the toughest part about it is it's a step change. It's not like you're like, oh, okay, I'm gonna just fly BVLOS for fun. It's just you have to make a commitment to it. So that's my takeaway for today.
Thank you, Rob, and thank you again, everyone, for joining the BVLOS Sync. We do plan to do this on a biannual basis, so stay tuned, and hopefully on the next one we'll definitely have some more information on Part 108 and new regulations, maybe new waivers being leveraged, as long as new use cases that we can highlight. So stay tuned and on the lookout for that. If you guys have any questions that we didn't answer today, connect with Austin Rains or Rob Knockenhauer on LinkedIn, or the companies, Census Technologies, Unmanned System, Frontier Precision Unmanned Systems. Check them out, connect with them, ask them questions. And this will be recorded, so it should be uploaded on our YouTube sometime soon. So if you want to watch it back because you missed something, feel free. And if you want the presentation, reach out to one of us as well. Thanks again for tuning in to BVLOS Sync, and have a good day.